Hello, my beautiful scholars, and this is our video review for math analysis. Going to hit the highlights here. We're going to start with some equations to solve. So we have root x plus x equals 1. This is a radical equation. And whenever we have a radical equation, we want to isolate the radical and then square both sides. So I'm going to move the x to the other side and get square root x equals 1 minus x. So we need to do the inverse operation in order to solve and undo the radical. So square and square. Remember, you can't just square each part. You have to square both sides collectively. So the square of the square root undoes the square root, and 1 minus x squared is 1 minus 2x plus x squared. Remember, you need to use the distributive property there if you can't do it in your head. Next, we need to combine like terms, and we need to set it equal to 0 because this is a quadratic equation. So we end up with 0 equals x squared, and I'm just putting this in descending order, minus 3x plus 1. Now this is not factorable because there are no factors of 1 that add up to 3. So we're going to need to use the quadratic formula here. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So this is pretty simply solved because the numbers are small. We get 9 minus 4, that is 5, and that is our answer. Now, what we need to check is, I'm going to do just a quick estimation here. The square root of 5 is slightly bigger than 2. The square root of 5 is slightly bigger than 2. So 3 minus 2 and some change is still a positive number. So even though we're subtracting root 5, it's still positive when we divide it by 2. Therefore, it will still maintain the domain restrictions from the given problem because of the square root. Next, we've got a rational equation. And when we have a rational equation, remember, we need a least common denominator. In order to find a least common denominator, we need to factor anything that can be factored. And obviously this can, and the other parts of the problem should give you a little hint as to what the factor should be if you need that hint. So when we factor this denominator, we see that it's x times x plus 2. So we're going to treat this kind of like the what's missing problems. So this side of the equation is not missing anything. This particular term is missing the x plus 2, so times x plus 2. So x minus 3 times x plus 2 all over the common denominator, x times x plus 2. This term is missing the x, so times x plus 3x. Now, once we get to here, remember, we can just basically cancel our common denominator. Because once we've got like denominators, all we have to do are compare the numerators by the one-to-one property. So follow order of operations and multiply here first. X minus 3 times x plus 2 is x squared minus x minus 6 equals negative 6. So here we've got a very simple quadratic equation. So let's dump the negative 6 from both sides, and we end up with x squared minus x equals 0. Let's factor right here, take out the x, and we get x times x minus 1 equals 0. Therefore, x equals 0, or positive 1. Now, if we go back to our original equation had denominators of x plus 2, and x times x plus 2. If we look back at those common denominators, we see that 1 will work because 1 is not going to make anything go to 0. But 0 will not work. It is extraneous because we can't plug in a 0 here or here because that will make the denominators go to 0. So when you go back and test your answers, 1 will work, 0 will not. Number 3, solving a rational inequality. So first thing we need to do, once again, get a common denominator and combine these two terms. So 5 times x minus 1 plus 3 times x plus 3 over x plus 3 times x minus 1 is greater than 0. Use order of operations and combine those like terms in the numerator. So 5x minus 5 plus 3x plus 9 over x plus 3 times x minus 1 strictly less than 0. Combine the like terms. So we've got a numerator which we will set equal to 0 because we're looking for critical values. Critical values. So if we do that, we see 8x equals negative 4, x equals negative 1/2. So there's our first critical value. Remember, they're going to go on the number line. And then, of course, our second critical value is going to be negative 3 because x plus 3 equals 0, x equals negative 3. X cannot be negative 3. That's a critical value. And then lastly, of course, x minus 1 equals 0, x equals 1. 1, 2, 3. We got to put them on the number line, and we're going to run some tests. So negative 3, negative 1/2, and a positive 1. Now, first of all, strictly less than, which means open circle, open circle, open circle. Open circle all the way across on that number line. Now from there, think of a value that is less than negative 3. How about, let's say, negative 4? So let's plug in a negative 4 right here, and let's see what we get. So first of all, 8 times negative 4 is negative 32 plus 4, so that would be a negative on the top. And then negative 4 plus 3 is negative 1. Negative 4 minus 1 is negative 5, so that would be a negative times a negative. So we end up with a negative over a positive, so this would all be negative. Anything to the left of negative 3 would yield a negative response. And a negative response is less than 0. So we do shade that particular interval. Now, let's look in this interval. So what's between negative 1/2 and negative 1? How about let's go with, or negative 3, let's go with negative 1. So we're going to do the same thing. Plug in a negative 1 here, here, and there. 8 times negative 1 is negative 8 plus 4. That's negative. Negative 1 plus 3 is 2, and that's positive. Negative 1 minus 1 is negative 2. That's negative. So we end up with, remember, we're multiplying down here, so that would be negative on the bottom. A negative divided by a negative is a positive. So everything in this interval would yield a positive amount, which is not greater than 0. Do not shade this interval. Finally, 0. That's the easiest thing to plug in. So if we plug in a 0, we get 4 on the top, which is positive. We get a positive here, and we get a negative here. So this becomes a positive divided by a negative, which is a negative. And a negative is less than 0. Shade that interval. We've seen in the past that basically this is going to be every other interval, but we're going to give one more check over here. We'll plug in a positive 2. So this is going to be 8 times 2 is 16 plus 4 is 20. That is positive. 2 plus 3 is 5. That is positive. And 2 minus 1 is positive. So we end up with everything positive, which of course is a positive, and a positive is not less than 0. So these are our intervals that will fulfill this particular inequality. So this is the number line. Then in interval notation, we get negative infinity to negative 3, parenthesis, union, negative 1/2 to 1, all in parenthesis. So the union of these two particular sets are going to make our inequality true. So there is our work right down there. Next, we've got a couple of graphs just to remind you about domain and range. Remember, the domain is read from the left to the right. So as we move from the left to the right, we see a definite starting point on the x-axis right there. So our domain is going to start at exactly x equals 2, and it is inclusive. So bracket on the 2. And then this particular graph continues to the right forever. So that means that our domain will begin at positive 2 and it will continue into positive infinity. Infinity is always bound with a parenthesis. Next, our range. Our range is read from the bottom to the top, and range has everything to do with the y-axis. So our range begins here. And once again, it's going up forever. So our range also starts at positive 2, inclusive, and goes to positive infinity. So that's domain, that's range. Domain, left to right, range, bottom to top. The second graph, and once again, we are going to the left forever and also to the right forever. So this particular graph has an unlimited domain, negative infinity to positive infinity. But the range does have a limitation. It is going down forever, but it does have a top, and it tops out at positive 3. So our range starts at negative infinity, but goes to positive 3 inclusive. So once again, domain left to right, range bottom to top. We did practice this in class the other day. Write a function of least degree with zeros at x equals 4, 5, and 3i. So, first zero, x minus 4 yields the 0, positive 4. Second zero, x minus 5 yields the 0, 5. The 3i is a little bit trickier. Let's use inverse operations in order to go backwards here. So if we have x equals 3i, the best way for us to get rid of the I is to square both sides. So x squared equals 3 squared, which is 9, and then I squared, which is I squared. And we know that I squared is going to be equal to negative 1. So wherever we see I squared, we are going to plug in negative 1. So I squared equals 9 times negative 1. I squared equals negative 9, and then we just need to move that negative 9 to the other side. I squared plus 9 is our factor. Remember, i's always come in pairs. That's why we're getting a quadratic factor here. So here are 3 factors. So 1, 2, 3, 4. Our degree of our function is going to be the 4th power. So 1, 2, 3, 4. So let's start multiplying. I'm going to start with the 2 linear factors first and get x squared minus 9x plus 20. And we're going to multiply that by x squared plus 9. And we're just using the distributive property. So x squared times x squared is x to the 4th. X squared times 9 plus 9x squared. Negative 9x times x squared is a minus 9x cubed. 9x times 9 minus 81x. 20 times x squared plus 20x squared. I'm going to take an opportunity to line up my like terms vertically. And then negative 9x times 9 is, 20 times 9, excuse me, is plus 180. So really my only like terms are right here. So x to the fourth plus 29x squared minus 9x cubed minus 81x plus 180. Now I'm just going to put this in descending order because that's what needs to be done. So f of x equals x to the fourth minus 9x cubed plus 29x squared minus 81x plus 180. So this is a function of least degree that has these three zeros. There we are. Now in the other direction, we're going to find all the zeros. And to find all the zeros, we are going to use our helpful friend, our little calculator here. And first thing I need to do is get zoomed in, so hopefully we can see everything. So the first thing we need to do is we need to graph this function. So we're going to graph this function. We're going to hit the y equals button, remember, in order to get to the y equals screen so we can start graphing. So plug in this function into your calculator. So x raised to the fourth minus 3x cubed minus 6x squared plus 6x plus 8. So x to the fourth, 3x cubed minus 6x squared plus 6x plus 8. Okay, graph it. We're looking for real zeros. And I can see that we've got a definite one at -1 and also 1, 2, 3, 4 at 4. So -1 and 4, those are the ones I can for certain see. So I'm going to use those to depress my polynomial down. So we know for certain that x equals -1 and +4. Now, it's going to say in the directions on our exam to justify your answers, and we justify our answers with division. So if we know those are real, we know 2 of them, we have 2 that are missing. They're probably going to be irrational. They're definitely there, they're definitely real, but they're probably going to be irrational. So here we go. So let's start with the +4, doing synthetic division. So 1, -3, -6, 6, and 8. Remember, we are expecting a remainder of 0 because this is a factor. This is a real root. When we use synthetic division, remember it's yo mama's division. We multiply and we add. So bring down the 1, multiply, add, multiply, add, multiply, add, and yes, we get a 0 right there. So we know it works. So I'm looking right there, and that is looking factorable. But being that I know I have a 0 in -1, I'm just going to use it and keep going. Once again, expecting a 0 right there when we divide by that root of -1. So bring down the 1, multiply, add, multiply, add, and multiply and add. And it does work. And this is what remains. So we just depressed down 2 times. So we've gone from a quartic function down to a quadratic function. And now let's just write that quadratic function, set it equal to 0, and let's solve it. So 1x squared minus 2 equals 0. X squared equals 2. And as I suspected, I knew we were going to get an irrational. It's real, it's just irrational. It is plus or minus the square root of 2. So our zeros are real and all the reals, there aren't any imaginary, but rational and irrational are -1, +4, and then plus or minus root 2 for finding all of our zeros. 2 more problems. This one is just a very straightforward long division problem. Remember, if we've got a coefficient other than 1, we need to do these with long division. So setting it up, 3, 2, 1, none. Every power of x is represented. That's a good thing. So we're not missing, and we have to plug in any zeros. So our divisor is 3x plus 2. So let's start dividing. Remember, we always start by looking at just the first terms when we divide, multiply, subtract, bring down. So 3x times x squared is going to give us that 3x cubed. So we just divided. Now we're going to multiply. X squared times 3x is 3x cubed. We always want these terms to be the same. If they're not, we've done something wrong. X squared times 2 plus 2x squared. And remember, we want to draw the line and change the signs. So this column should always cancel. 3 minus 3 cancels. 5 minus 2, 3x squared. And we just subtracted. Now we're going to bring down. Keep all your terms lined up as neatly as possible. And then do your comparison again. 3x squared divided by 3x is simply plus x. X times 3x is 3x squared. X times 2 plus 2x. Draw the line, change the sign in order to subtract. That should always cancel. 8 minus 2, 6x. Bring down, plus 7. 3x goes into 6x plus 2 times. 2 times 3x is 6x. 2 times 2 is 4. Last time, draw the line, change the signs. First term always cancels. 7 minus 4 is 3. So we have a quotient of x squared plus x plus 2 and a remainder of 3 over 3x plus 2. Quotient plus remainder over divisor. Last problem, scholars, this is one of our most current problems that we worked on in our logs chapter. Solve in terms of the natural log. I'm dictating that I want the answer in terms of the natural log. So 3 and 7 have nothing in common. So our only option is to use a logarithm, and I want it to be the natural log. So we are going to take the natural log of both sides, and when we invoke a logarithm, that allows us to Superman those powers to the front. So our problem is turning into x plus 2 times ln of 3. 2x minus 5 times ln of 7. Remember, ln of 3 is a constant value that we are now going to distribute. So x ln 3 plus 2 ln 3 equals 2x ln 7 minus 5 ln 7. So identify the parts of the equation that have an x. If they have an x, we want to put them on the left. If they don't have an x, we want to put them on the right. So here goes. X ln 3. This is positive on the right, so when we move it to the left, it becomes negative. So minus 2x ln 7 equals, all right, done with those, negative 5 ln 7. This is going from the left to the right. It is positive, so it will become minus 2 ln 3. So once we have grouped together the somewhat like terms, what we need to realize is that x right here is the GCF. It's the GCF that we are going to factor out. So x times ln 3 minus 2 ln 7 equals negative 5 ln 7 minus 2 ln 3. So this is what we are going to now divide both sides by. Cancel, cancel, and this is our answer in terms of the natural log. So There's x. X equals negative 5 ln 7 minus 2 ln 3 all over ln 3 minus 2 ln 7.